Algebra 2, Unit 2 notes. That's right. All of Unit 2 is going to be right here. There are 2 days worth. There are 2 practices on ALEKS for you to do from this. But the days are short enough where we would do this in one class period as far as giving you the notes. So we're going to do it in one notes video. All right, so let's take a look at this first page here. Talking about absolute values, okay, which we looked at the end of Unit 1. So with Unit 2, we start a refresher on absolute value. The definition of absolute value is the distance away from 0 on a number line that some number is, okay? And it's always going to be positive. Okay? Like it's saying, how far is it from here to the store? It's 3 miles. How far is it from the store back to here? It's also 3 miles. You never say, I traveled -3 miles. So it doesn't matter if you're going to the right or to the left, absolute value is the positive distance from 0. Okay, so an example, the absolute value of -4. Well, how far away from 0 was -4? It's 4 units away. So we say it's 4. Absolute value of +4. That is also 4 units from 0. So the absolute value sticks. Okay, and that's what, I'll be calling them sticks sometimes. They are actually brackets, absolute value brackets. But when I get to solving, we're going to say isolate the sticks. All right, so those absolute value brackets, those are the sticks. All right. All right, so now let's think about what x equals for each of the following equations. State all of your solutions. All right, pay attention on this. It's quick, it's pretty easy, but if you don't get this, you won't be able to grasp the future concepts here in this notes session. Okay, the absolute value of x is 4. Well, look right up here. We saw that the absolute value of +4 is 4. Or the absolute value of -4 is also 4. So both of these answers are good. So when we have the absolute value of x equals 4, we can split into saying x is 4 or x is -4. Now what about when the absolute value of x is 0? Well, obviously, you're not going to go 0 and -0. You're just going to say x is got to be 0 because the absolute value of 0 is 0. This last one, if I have the absolute value is equal to a negative number, can't happen, right? There is no solution because the absolute value must be 0 or positive number. So we would say no solution. There is nothing I could put in for x that would give me the absolute value equal to -4. No solution. Right? So now let's look at these and make sense of them graphically. So if you had a graphing calculator and you put them in your graphing calculator, if you put in the absolute value of x under y1 and you put 4 for y2, okay, you would get this graph. So this here is the line y equals 4. It's a nice horizontal line through the y-axis at 4. And then you have the parent function y equals absolute value of x. Okay, so notice that there are 2, that's right, 2 times the 4 and the absolute value of x intersect. And they are at -4 and at +4, okay, which is exactly what we had for our answer. When we look at absolute value of x equals 0, we have the line y equals 0, which is actually the x-axis, okay, this guy right here. Okay? And we have the parent function y equals absolute value of x going right here. And where do they intersect? They don't intersect at 1, 2 points like this graph did. They only intersect right here at the origin, okay, which again is reinforcing what we just had there at 0. Okay, so now the one I think is the most interesting of the 3, if you look at this absolute value of x parent function one more time, And now this time, look at y equals -4, this line right here. You see that the -4 and that parent function, absolute value of x, they never intersect. There is no intersection. So no intersection, that's no solution. And once again, it just reinforces what we looked at up above. Okay? So let's scoot down here. 3 examples to do where we have more than just absolute value of x. Let's get some practice on these. All right, so 2 steppers really here. Step 1 is always isolate the sticks. And the sticks, as I mentioned, are the absolute value brackets, right? So in question 1, the sticks are already isolated on the left side of the equal sign, okay? There's nothing else on the left side, just the absolute value brackets or the sticks. So they are isolated. So if we got the isolated sticks, we are now going to split this equation into 2 equations. Because we know what that 2u plus 10 must equal, right? It must equal, in this case, 0 or -0. So we're not even going to split this one. Because it's a 0, I'm just going to erase one. I'm going to erase this here. We're going to drop the absolute values, and we're going to say 2u plus 10 must be 0. Okay? If it said 2u plus 10 absolute value is 1, then we'd have 2u plus 10 would equal 1, or 2u plus 10 equals -1. For 0, 0 or -0, it's the same thing, so there's no need to split it. Just drop your absolute values, and then let's finish it here. Go -10 to both sides. That's a 10, trust me. Okay, so we got 2u equals -10, divide by 2. We got u is equal to -5. Go back to the beginning. 2 times -5 is -10. -10 plus 10 is 0. And then the absolute value of 0 is 0. So it's right on the money. We got it. Okay? Let's look at the second question. Again, first step is always isolate the sticks. If you look, the sticks are on the left side of the equal sign, but there's something with them. There's a -3, okay? Do not do this. Do not do this, because that -3 is not being added or subtracted. That -3 is multiplying. So we're going to divide by -3. That's a negative. Try that again. -3. There we go. Divide the other side by -3. Okay. So -3's cancel on this side, leaving me with the absolute value of v minus 4. 33 divided by -3 is -11. Okay, so now here is my little checklist I'm giving you. If after you've isolated the sticks, it says equals 0, like we did in question 1, we just solve it. Okay, drop your sticks and just solve it as if it's an Algebra 1 question. If it says equals a negative number, we know the absolute value can never, ever equal a negative number. So when it says the absolute value of v minus 4, the absolute value of who cares? Doesn't matter. If it says absolute value of anything equals negative anything, then we immediately say that is no solution. Okay, let's finish this page right here. We're going to isolate the sticks again. So the sticks are on the left side of the equal sign, but we've got this -8 and we got this -2. Okay, always cancel plus minus first. Okay? I'm talking about outside of the sticks. So the -8, we're going to cancel that with a +8. We're going to add 8 to both sides of the equal sign. And that gives us -2 times the absolute value of x plus 3. And then equals -20 plus 8, which is -12. Now we have to cancel this -2 out to isolate the sticks. We got to isolate those absolute value brackets. So again, this is multiplication, so we're going to divide by -2, divide by -2. So those cancel nicely, and we've got the absolute value of x plus 3 equals 6. Right, well, looking down here again, we isolated the sticks, and once you isolate the sticks, if it says equals a positive number, like this says equals +6, then we're going to split and solve. We're going to drop the sticks, and we're going to say that x plus 3 could equal 6, because the absolute value of 6 is 6. But that x plus 3 could also be -6, because the absolute value of -6 is 6. So for both of these, we would subtract 3 from both sides. Okay, so we got x equals 6 minus 3, or 3. Here we've got x equals, notice this one's not 3 or -3. -6 subtract 3 is -9. Okay. If you want to go right back up there and substitute each of those in and see if both of those would give you -20, go for it. That's how we check our answers. Okay. I would be happy to do that individually if you needed it, but for the sake of the notes being as short as possible, let's move on to the second day's worth of notes. Okay, so now we are going to, instead of having an equal sign, we're going to have an inequality symbol. These are your inequality symbols. Okay, you learned them back in grade school. Okay, whether your teacher called them the alligator mouth or whatever they wanted to call them, didn't matter. But you've got less than, you got less than or equal to. So remember that the or equal to is dependent upon that little line underneath the alligator mouth. You got greater than, and you got greater than or equal to, because you got, again, that little line underneath the alligator mouth. So that means that it's equal to that, that amount as well. Okay? So let's graph this. X is less than or equal to 3. Okay, let's get something bright here. So I'm going to go to 3. It says less than or equal to, so we're going to do a solid circle. We put it on 3, and it says less than, so we're going to be going this way. Okay, I'm not going to put my arrow on just yet. You'll see why in a second. Greater than or equal to -3, so I'm going to start at -3. Again, it's or equal to, so I put a solid circle, no open circle. And it says greater than, so I'm going to go to the right. Well, look at this. These guys kind of meet. Okay? So the fact that it says and means it has to be all points that are in both of these, the red and the orange solutions. So the only solution that we have is all the points between -3 and 3. Okay, so everything between the two significant points of 3 and -3. So notice that this is an and. And is going to be the points going towards each other, and they're going to have two endpoints. Now let's look over here to the side, and we got this guy. X is less than or equal to -3, so we'll go to -3 here, or equal to, so again, solid circle. Less than, we're going this way. Okay, or x is greater than or equal to 3. So start at 3. It's or equal to, so solid circle, filled in circle, and greater than, so we go to the right. So because these two arrows do not face each other, okay, you do not take the points in between them, because there is no number that is both greater than 3 and at the same time less than -3. Over here, there were numbers that could be less than 3 and greater than -3, right? But that's why this one over here is an or, because it's either got to be here or here. It can't be both, okay? So for each of the following, graph the solution set on the number line. The absolute value of x is less than or equal to 3. So the distance from 0, which is what absolute value means, must be less than or equal to 3, all right? So, let's do this algebraically as well, right? Because we have the sticks isolated, we could split this into saying x is less than or equal to 3, also x greater than or equal to -3. Because what points are 3 units away from 0? Well, 3 and -3. Okay, so this is or equal to, so I'm going to put solid dots here, solid points. All right. This is something that I've found that students liked and they remembered well. If we're dealing with inequalities, if we have a less than, okay, so this was less than, okay, the fact that it was less than, we like to say less than, because it's going to be an and your solution is going to be in between the two critical points of 3 and -3. Okay, so less than, the two arrows are going to be going at each other, right? And you're going to have shading between the 2 points. Okay, this guy over here, switch the color up. All right, this says absolute value of x is greater than 3. Again, we can split this up. X is greater than 3. X is less than -3. Okay, notice on these, when we change the direction in the middle, change the direction of the inequality, that's when we change the sign of the number on the right. So we changed this and we changed that. So again, the absolute value of x is greater than 3. So you start at 3, right? Now, this is not greater than or equal to, this is just greater. So we open circle because of the greater, right? And it's greater, so it's going to the right. Less than -3, we start at -3 again, open circle because it's not less than or equal to. And less than goes to the left. So just like we had the little memory device of less than, we also have this one, greater. So because it's greater, we come back to the or compound inequality and we say those arrows are going to be going in the opposite direction. That's an or, all right? So it's either this interval or this interval, okay? Whereas for here, it was an and. Okay? It was this and this at the same time. Okay, move on just a bit. Down the page, we're going to solve these guys. Okay? We're always going to isolate the sticks. All right, that's the big part. First thing we're going to do, isolate the sticks. So on this first question, the sticks are on the left side of the inequality symbol. We have to isolate them by canceling this -5. So let's add 5. Let's add 5. Okay? So what we've got is the absolute value of x is less than or equal to 4 plus 5, which is 9. Okay, so look, anytime that you have positive over here on this side, doesn't matter if it's greater than or less than or equal to positive, we are always going to split and solve. Okay. And then in the end, we're going to ask, is it an and or an or? Well, always go right back to here. What is this symbol? The absolute value of x is, now this is a less than or equal to. So because it's less than, it's going to be an and. Okay? So I know from this right here, once I've isolated the sticks, I know that my little symbol here tells me this is going to be an and in the end. Okay? Now, there's a few steps in here, so keep them straight. All right, because it was a positive 9, we're going to start with x, just like it's written there. I'm going to drop those sticks, say that x could be less than or equal to 9. At the same time, again, drop the sticks, the x. Now we're going to turn the symbol, turn the inequality, and we're going to also change the sign of the number. Okay? So x is less than or equal to 9. X is greater than or equal to negative 9. Okay? So now because this is an and, how do I know? Well, I mean, you can either know it by remembering less than, or I could just ask you, is there any number that can be both less than or equal to 9 and at the same time greater than or equal to negative 9? Sure, lots of them. 0, 1, 2, 3, 4, negative 1, negative, tons of them, infinite numbers actually. Okay, so because it can be both, this is an and. So your Alex may very well allow you to just write the word and in between them. I would say this, you can also do this. If it is an and, you can put your x here. You can put your lesser one on the left, less than or equal to x. And then you put your bigger one on the right. Okay? This is another good answer. This says x is greater than or equal to negative 9 and less than or equal to 9. Okay? Both of these answers are fine. Okay? They're both correct. So let's look at question 2. Question 2, the sticks are already isolated. It's on the left side of the inequality. On the right side is a positive number. So because it's positive, we're going to split. So we can do a little solving here. So 2x minus 3, what's inside? Okay, notice we dropped the sticks and we're going to bring down the greater than 5. Then we're going to still drop the sticks for the other inequality, but we're going to change the direction of our inequality symbol, and we're going to change the sign of the number over there. Tell you, that is something that will get a lot of people. Okay, some people will lose some points on this. You must change the symbol and change the sign of the number. Both. You must do both. All right. So next up, let's solve for x. So we're going to add 3. Add 3. Okay, so we've got 2x is greater than 5 plus 3, which is 8. Okay, so we got 2x is greater than 8. And then we got 2x is greater than negative 5 plus 3, which is negative 2. Let's don't forget our symbol here. Less than negative 2. Okay, now we divide by 2. Divide by 2. Divide by 2. So we've got x is greater than 4. and then we divide this one by 2, divide this one by 2. We get x is less than -1. Okay, so we got x is greater than 4. We got x is less than -1. So you can either ask yourself, is there any number that's bigger than 4, but at the same time less than -1? And you say no. So it cannot be an and, it must be an or. So you can write the word or in between there. So x is greater than 4 or x is less than -1. All of those numbers will work to make this a true statement up top. Or you can go back to where the sticks were isolated. That was greater than, greater, or, greater. So you've got the or in between your two answer solution intervals. Okay. All right. Next up, number 3. Let's look at it. So are the sticks isolated? They're on the left side. There's something with the sticks. There's a 3. Don't want anything with the sticks. Want to isolate them. So we got to divide by 3, divide by 3. So we've got the absolute value of x plus 1. I divided by a positive, so I'm not going to change the direction of anything. 18 divided by 3 is 6. Okay. Once again, this is a positive number. A positive number. So we are going to split it. By the way, is it going to be greater than, excuse me, is it going to be or and? Okay, since we have already got the sticks isolated, you can just look at this. So it's the absolute value is greater than, okay? So anytime you say the word greater, it's greater. So we know our answer is going to have an or in between it. Okay, so we can drop the sticks, say that x plus 1 could be greater than or equal to 6. Can also say, again, drop the sticks. X plus 1 is less than or equal to -6. Okay, so we change the symbol's direction and we change the sign of the number on the right. Let's solve. I'm going to go -1, -1, -1, -1. Okay, so you got x is greater than or equal to 6. X is less than or equal to -7. Now, can any number be greater than or equal to 6 and at the same time be less than or equal to -7? Of course not. That's why we knew it would be or. Okay, just like back here, it was greater than. So I'm going to put the word or in between these two inequality symbols. X is greater than or equal to 6, or it's x has got to be less than or equal to -7. Okay. Continue. Last one in this set. Exciting stuff, right? Again, we are going to isolate the sticks. The sticks are on the left side. The sticks have a 2 in front of them, and they have a +5 behind them. We got to get rid of both. We got to cancel them. Well, as I said before, you got to cancel the plus minus first. At least you should. And it just gives you less opportunities for mistakes. So that +5, let's cancel it out with a -5. Yeah. Okay, so that gives us 2 times the absolute value of v minus 3. 5's cancel nicely. Less than 12. So now we got to cancel the 2 so we can isolate the sticks. So we're going to divide by 2. Divide by 2. So we get the absolute value of v minus 3 is less than 6. Top notch. Here we go. This is positive. We're going to split it. By the way, is it going to be an and or an or? What's this? Now that we got it split, you can say, I know what it's going to be. You hopefully are saying that's less than, It's less than, so it's going to be an and. Okay. Here we go. V minus 3 less than 6. Okay. Again, we drop the sticks. Make sure you drop the sticks when you do your solving. Okay. And v minus 3, and now we got to change the symbol, okay, turn the symbol, the inequality symbol, and then we take the 6 and we make it negative. All right, so I'm gonna add 3, add 3, add 3, lots of plus 3s all over the place here. Okay, so I got V less than 9, V greater than negative 3. Okay, so is there any number that is less than 9 and at the same time is greater than negative 3? Less than 9, greater than negative 3. Sure, tons of them. 0 is less than 9 but bigger than negative 3. Okay? That means it could be both. This is an and. So you can either write and in between them. So that's a good answer. Or you could make this a compound inequality by saying V, now take the smaller one, put it on the left, negative 3. Okay, now these don't have or equal to's in them, so we're not going to put the line underneath. And then take the bigger one, put it on the right. Boom. So that is also a great way to write it. Those are both correct. We're done. That's it. That's all of Unit 2. Okay, this is what's on your test coming up. So please make sure that you do both practices, do that review and do it thoroughly and ask questions. And you know, if you need support, reach out. Okay, we can Zoom, we can do whatever you need to do, but make sure that you get your questions answered. Okay, that's it. Day 2 is down. See ya.